Welcome back to the tutorial session. For the quiz, I'm going to explain to you how you should answer the quiz question for chapter 2 acidometry. So altogether you have 3 different questions. So I'm going to go through it one by one, and I hope you can understand how you should tackle all these questions. So let's get started. Alright, if you can see in your question, altogether they have 3 questions, so I'm going to go through question number 1. 4.90 gram of pure sulfuric acid was dissolved in water where the resulting total volume was 200 centimeter cube. 20.7 centimeter cube of this solution was used to neutralize 10 centimeter cube of sodium hydroxide solution. So approximate the pH of the sodium hydroxide used in this reaction. So when you have this kind of question, the thing that you need to bear in mind is that you need to know what is actually the reaction occurring. So in here you can see that the reaction is the neutralization reaction. So when you have neutralization reaction, one of the product that is going to be produced is water, and then you need to look at the reactant that play a role in this type of reaction. So in here you have sulfuric acid and also sodium hydroxide. So the first thing that you need to do is that you need to make sure that you know how to write a balanced equation. So at first you will have pure sulfuric acid, H2SO4, and then you will neutralize it with sodium hydroxide plus sodium hydroxide. So what is the product? So because it is a neutralization process, so definitely you will have H2O plus. Okay, what is it? What are the other product? So because you have H2O here, so you are going to remove this part and one of this. So you should have SO4 and also Na. So SO4 you should know is SO4 2 minus, and Na is Na plus. So therefore when you create the product, because Na you have Na plus, right? But this one you have 2 minus, so it become Na2SO4. Okay, now the next thing that you need to do is you need to balance out this equation. So how are you going to balance this out? So you look at the number of hydrogen. So you have 2 hydrogen here, right? So you have 2 hydrogen and another one. So you actually have 3 hydrogen. So it's not enough, but that's fine. We are looking at the oxygen next. So 4 plus another one. So it's going to be 5. It's hard, right, to get 5, but see, 4 plus 1 is 5. It's okay already for the oxygen. But if you look at the sodium here, you have 2 sodium. So definitely here you need to add 2, so that you have 2 sodium over here. So when you have 2 sodium over here, it means that your oxygen become 2. So 2 plus 4, 6. So 6. In order for you to get this 6, what do you need to do? Because you already have 4, so 6 minus 4, you need 2, right? So you need to times 2. So 2 times 2 equals 4. So here you have 2 times 2 equals 2, 2 times 1 equals 2, plus another 2 is 4. So this is your balanced equation. So this is balanced already. Next, you need to look again at your question. See, in the question, it states here that 4.90 gram of pure sulfuric acid was dissolved in water so that the resulting total volume was 200 centimeter cube. So you have the mass. So when you have the mass given to you equivalent to 4.90 gram of sulfuric acid, H2 SO4, right? So when you have the mass, what you can calculate is the number of mole. So the number of mole is equivalent to mass over RMM. So the mass of H2SO4, the mass is 4.90. So what is the RMM for H2SO4? How are you going to get the RMM? Therefore, you need to use this table. So we have atomic number and atomic mass. So RMM, relative molar mass. So you're going to look at the mass. So you need to look what is the value, the atomic mass for hydrogen and also for oxygen and also for sulfur. So I'm going to show you one. So for hydrogen here is 1.0079. So because you have two hydrogen, right? So 2 times 1.0079. Okay, that's for hydrogen. And then for sulfur, it should be 32.06. And then for oxygen here, because you have 4 oxygen, so 4 times 15.9994. Okay, after that, you should get your number of mole is equivalent to 0.0499 mole. Okay, so this is the first step. And then when you look at the question again, it says that the total volume is equivalent to 200 centimeter cube. So remember, when you want to calculate the molarity, the volume must be in liter. So 200 centimeter cube, you need to convert into liter. So 200 divided by 1000 equivalent to, so 1, 2, 3, 0.2 liter. So from here you can grab the molarity of this solution. So molarity equivalent to mole over. So what is the number of mole? So the number of mole is here 0.0499. Liter is 0.2. So you should get the molarity is equivalent to 0.24995 molar. Okay, this is your second thing that you need to calculate. Alright. So now I'm going to recap what we have calculated just now. So first and foremost, we calculated the number of mole for H2SO4. So the number of mole for H2SO4 is equivalent to 0.0499 mole. Right. Right after that, we have calculated the molarity of H2SO4, and what we gain is 0.24995 molar. So, and then if you look through the question, it states here that only 20.7 centimeter cube of the solution is being used. So, only 20.7 centimeter cube. Okay, same drill. 20.7 centimeter cube. You need to convert it to liter. So 1, 2, 3. So you should get 0.0207 liter. So from here, because since that you only use this much, so you need to calculate back how much mole of this H2SO4 is being used inside this reaction. So molarity is equivalent to mole over liter. So since you know that the molarity of this solution, this is the molarity, so you bring it here. So 0.24995 equivalent to the mole that you want to find, and how much the volume that you use is actually this one. So you put it here. So you should get 0.0207. Therefore, number of mole is equivalent to 0.0207 times 0.24995. So you should get altogether 5.1739 times 10 to the power of negative 3 mole. Alright, so you have the number of mole already, and then we are going to go back to our chemical equation just now that we have done, because it says that it neutralized 10 centimeter cube of sodium hydroxide. So from here we need to know the ratio. So actually the chemical reaction that we have done just now is H2SO4 plus 2NaOH will produce Na2SO4 plus 2H2O. Alright, so from here, if you can see, for each 1 mole of H2SO4, you will need 2 mole of NaOH, right? So how much mole of H2O4 that is being used in this reaction is this much. So 5.1739 times 10 to the power of negative 3. Supposedly, you should have 2 times 5.1739 times 10 to the power of negative 3. So how much sodium hydroxide that you should have is actually 0.0104 NaOH. Right, this is the number of mole, because it states in the question is that it's being used to neutralize. So we assume that it should go until the end of the reaction. So this is how much sodium hydroxide is being used inside this reaction. So, but because the question asks you to calculate what is the pH, so definitely you need to calculate the concentration of sodium hydroxide first. So molarity or the concentration equivalent to mole over liter. So the number of mole is this one, 0.0104. How much? So how much sodium hydroxide is being used? So you look back at the question. So to neutralize 10 centimeter cube, so 10 centimeter cube, still you need to convert it to liter. So it become just divide by 1000, 0.01. So you should get the molarity for sodium hydroxide in this equation equivalent to 1.04 molar. Okay, so this is not ended yet because you were asked to calculate the pH. So sodium hydroxide is what we consider as a strong base. Therefore, the concentration of the OH is equivalent to the concentration of the NaOH itself. So since NaOH is a base, not an acid, so you need to calculate POH is equivalent to negative log concentration of OH minus. So this is the concentration of OH minus. So concentration of NaOH equivalent to concentration of OH minus. So negative log 1.04. So you should get the POH of this is negative 0.017. Okay, so but this is we have not end this question yet. It's so long. So because you were asked to calculate the pH, right? Now we only get the pOH. So we need to use this value of the pOH, right? So the pOH, so we need to do the pH plus pOH equivalent to 14, right? Okay. So pH plus pOH equivalent to 14. So pH equivalent to 14 because your pOH is negative, right? So negative, so become here negative 0.017. Okay, because pH, you bring the pOH here, so you will get your pH should be equivalent to 14.017. So this is your final answer.